Hi folks, this is Nat, and this is going to be a video lesson on dividing with fractions, and also because it's an essential skill for dividing with fractions, we're going to be looking at how we convert between improper fractions and mixed numbers, which is actually where we're going to start off today. Improper fractions and mixed numbers are two ways of expressing the same sorts of ideas, basically when a fraction gets bigger than 1. For example, let's say that we were adding and we did 7/8 plus 2/3. I'm going to remember my good adding skills here, and I'm going to make sure I have a common denominator. In this case, the least common denominator for 8 and 3 is going to be 24, which I get by just multiplying by the other. And I'm going to do the same things to the top and the bottom so that I don't mess anything up and get a non-equivalent fraction. So I have 21 24ths, and I'm going to be adding that to 16 24ths, and that is going to be an improper fraction because it adds up to 37 24ths, meaning I have more than a whole here. Now, if you're talking about probabilities, that's impossible, but for lots of other fraction applications, this happens. Say you're adding 2 parts of an inch together. Well, you now have gotten up to more than an inch. It's perfectly fine in a lot of scenarios, first of all, to leave this fraction as an improper fraction. And generally speaking, the further you go in math, the more we like improper fractions. They're actually really great, so don't think that improper fractions are terrible and that you always have to change them. But sometimes it makes sense to change them. And in that case, we want to convert them to a mixed number. And when I convert a fraction to a mixed number, all I'm really doing is thinking about how many wholes fit inside that thing. A whole, what makes a whole, is typically determined by the denominator. So if we look at the denominator here, 24, that means there's 24 pieces in a whole. So a whole would be having all 24 of the 24 pieces. So if my denominator is 24, a whole is 24 24ths, or 1. And it's really worth noting that a whole can really be anything. It's always 1, but it could be 9/9 or 15/15. All of these things are wholes because if we look, we can say, okay, the denominator tells us how many pieces, and I've got all of the pieces out of the number I could have. Same thing here, 9 pieces out of 9 pieces. That's all the pieces. It's a whole. So recognizing wholes and being able to express wholes in a variety of different ways is going to be important to us. In this case, like we said, a whole is based on the denominator 24, so 24 24ths is a whole. And I'm going to start breaking this number up. I can say to myself, well, 37 24ths is 24 24ths with an additional, what's left over, 13 24ths? I think so. And these two things actually mean the same thing. 37 24ths is the same as 24 24ths plus 13 24ths. And turning a fraction into a mixed number is really just a matter of taking that whole over here and calling it what it is, a whole, 1. So 37 24ths is 1 whole and 13 24ths. Sometimes there's more than one whole inside of something. So let's take an example. Let's say you see the fraction 15 fourths. That's an improper fraction, and again, there's nothing wrong with that, but let's say we need to turn it or want to turn it into a mixed number for any reason. So 15 fourths. There's a bunch of ways to think about this. First of all, I'm going to say, okay, a whole in this scenario is 4 fourths. And one thing I could think about is how many 4 fourths can I get out of 15 fourths? Well, there's 4 fourths. 4 fourths more would be 8 fourths. Then 4 more fourths would be 12 fourths. And what's left is 3 fourths. So this collectively is the same as 15 fourths. And if we look here, I've got 1, 2, 3 wholes, and 3 fourths left over. So I can very easily call this 3 wholes and 3 fourths remaining, 3 and 3 fourths. Once you get good at this, it tends to go faster because you tend to just think of the fraction as a division problem, and you might say to yourself, okay, 15 fourths, 15 divided by 4. How many times can 4 go into 15 without going over? The answer is 3, because that's 12. And you say, well, what's left over? 3/4 remaining. So same answer, just an abbreviated way of getting to it. Changing a mixed number into a fraction is the exact same the exact same operation, but in reverse. So let's say I have 1 and 7/8. Okay, and I want to change that mixed number into an improper fraction. There's a lot of good reasons to do this. The one we're going to be thinking about today is that I can't actually multiply and divide mixed numbers, so I always have to convert them to improper fractions. So let's say I need to do that. I could think of this the same idea. In the same way, this whole here, because my denominator that I'm looking at is 8/8, it makes sense to think of this whole as being 8/8. I have 8 pieces out of 8 possible pieces, and then I have 7/8 as a fraction. If I combine those together, I end up with 15/8, and that's my improper fraction version of that. What confuses some students, and it's reasonable because you could literally turn this whole into any whole fraction. It could have been 8/8 like we did, but it also could have been 7/7 or 5/5 or 100 hundredths. And so since you have an infinite number of choices, a lot of students have trouble knowing what to do. The way you can make it easier on yourself is recognizing that I'm trying to match up to the denominator of the fraction. So when I see that the denominator is 8, I must then be thinking, okay, well that's 8/8, not 7/7 or 100 hundredths. Here's another quick example. Let's say that I'm looking at 3 and 4/5. Well, breaking this up, I have 3 wholes. And since I'm using the denominator fifths, I might think of those 3 wholes as 5/5, that's 1, 5/5, that's 2, and 5/5, that's 3, and then 4/5 as a fraction. And if I put all those together, 5/5, 5/5, 5/5, and 4/5, it makes 19/5. Again, my 5/5 came from my 3 wholes. They're my 3 wholes, 5/5, and 4/5 is still the fraction. Now, this gets a little bit tricky and not worth doing this long way once numbers get large. Like if I'm looking at, I don't know, even 8 and 7/8, let's say. Drawing out 8 wholes and adding 8/8 8 times is a giant pain. So we have to start recognizing patterns here and using those. As I look at this, I notice that I always have the number of wholes that I see, and they're always according to the denominator. So 3/5, 3 sets of 5 is 15. And you're going to notice that that covers all of the combined numerators. 3 sets of 5 is 15. Plus an additional 4. Same thing here. I'm going to notice that I have 8 wholes, so that's going to be 8 sets of 8/8. 8 sets of 8 is 64 total 8s, plus the 7/8 is going to give me a grand total of 71/8 as an improper fraction. So we have that ability to speed things up. A lot of people like to just remember, I'm going to take my whole number times my denominator and add my numerator to get the numerator of the new improper fraction, and the denominator just stays the same. You'll notice in none of these conversions does the denominator ever have to change, which is convenient. And that gets us to the idea of dividing fractions, because if you know how to convert mixed numbers to improper fractions, you're in pretty good shape for dividing fractions in any situation. The first thing to understand about dividing fractions is it's really just like dividing whole numbers, except harder to imagine in your head. For example, if you think about 3 divided by 1/3, I'm basically asking how many sets of 1/3 can I get out of 3? And if I imagine 3 as 3 wholes, each made up of 3/3, I'll notice that I can get 9/3 out of 3 wholes. So the answer is 9. If you're working with two fractions, let's say I have 4/5 and I divide that by 1/5. Well, same idea. I can think first of all about a whole made up of fifths, and then how many 1/5, if I have 4, 1, 2, 3, 4, how many 1/5s can I get out of that? Well, there's 1/5, there's 1/5, there's 1/5, and there's 1/5. So 4/5 are inside 4/5. So I can, just split them the way I've normally been doing. Now that gets a little bit tricky if the denominators don't work well together. So beyond understanding what we're doing, we want to know the rule that goes along with fractions. And we can use these two problems we've just solved to sort of illustrate that rule. The rule has a nice little rhyme to it. We always skip and then flip. And here's what I mean by that. We're always going to leave the first number we see alone. We skip it. So when I see 3 in my first one here, I'm going to leave that as 3, although I am going to change it to the fraction 3 over 1. Anything could always be over 1, and it's the same thing. I need two fractions when I divide fractions. So 3 is 3 over 1, but I'm going to skip it, I'm going to leave it alone, and then I'm going to flip the second fraction. In other words, I'm going to turn it upside down. This is called the reciprocal. So 3 over 1, and now 3 over 1 when I flip the second fraction. The other thing I do is X out that division and change it to multiplication, because dividing a fraction is the same as multiplying by the reciprocal, and that's the rule we use. So instead of dividing, which is kind of a pain, by 1/3, I'm actually going to multiply by 3/1 instead. And that'll give me the answer. 3 times 3 is 9. Again, I'm just going to multiply straight across, and 1 times 1 is 1. So 9 wholes, 9 ones is 9, just like we found a second ago. Let's apply it in the second situation. I'm going to skip the first number, so 4/5 stays the same, and I'm going to flip the second. 1/5 becomes 5/1. Again, I'm going to take out that division and replace it with multiplication. So 4 times 5 is 20. 5 times 1 is 5, and if I reduce that, 20/5 is actually 4 wholes. Again, that's the exact same answer I got a second ago. So this is a rule that'll work no matter what. Say I'm doing something more complicated, like 3/5 divided by 1/4, and I notice it doesn't go in evenly. So this would be a pain if I actually had to draw it out or something like that. So what I'm going to do instead is I'm going to say, okay, I'm just going to follow the rule. I'm going to skip the first thing, so I'm going to leave 3/5 alone, and I'm going to flip the second, 4 over 1 instead of 1 over 4. I'm going to take out my division, and I'm going to turn it into a multiplication problem and multiply straight across. 3 times 4 is 12. 5 times 1 is 5. Now I could leave that as an improper fraction, or I could convert it to the mixed number, 2 wholes with 2/5 remaining, so 2 and 2/5. Either one of those would be fine. You add a step when you deal with mixed numbers because we can't actually multiply mixed numbers, and so we can't divide mixed numbers either. So if you find yourself with a multiplication or division problem involving mixed numbers, the first thing is to convert those. So I'm not going to change my sign yet, but I'm going to convert 2 1/2 to 5/2 divided by 4/5. Now I have not changed anything. I've just converted my 2 1/2 to its equivalent improper fraction. Now I'm ready to do my division rule and skip the 5/2, leave it alone, and flip the 4/5 to 5/4. And I'm going to again replace my division with multiplication and multiply straight across, 25/8. Or again, if I want that as a mixed number, 3 1/8. The same thing would be true for any multiplication problems involving mixed numbers. I would have to convert those to improper fractions before I could multiply. And here are your practice problems for the lesson. There's 4 of them. Make sure you do all of them. Remember on number 4, you've got an improper fraction there, so you're going to need to convert that before you're able to divide. Good luck.